I will have, because these three sessions, coming three sessions today, the next weekend, and the following weekend, we will have an integrated session. That means we will learn GitLab, we will learn our awareness with Terraform and Ansible. With these three tools, we are going to do some hands-on activity. But before we do this hands-on activity, we should be understanding the topic, what we are trying to achieve, and what is that. So it is not a full-fledged, I cannot deliver within 6 hours, which is three sessions. A very, very important DevOps tools like GitLab, Ansible, and Terraform. It is not possible, but yes, I will try my level best to at least give you a head start, and you will be feeling excited that okay, yes, that is why we should be learning this beautiful tools. Okay, uh, so I will start with GitLab. So here I will go through few slides to give you a theoretical background of GitLab, which is a pipeline CI/CD, a continuous integration and continuous delivery and deployment tool, which is an integration tool, and the other tools that will be integrated with the pipeline of GitLab will be Terraform and Ansible. Before we go into the next phase of our learning, which is absolutely container based, the Docker and Kubernetes. So I'm keeping that part away for the last three sessions, but these coming three sessions, including this one, will be on the GitLab, on Ansible and Terraform. Is that point clear? Let me have a diagram. Let me have a diagram of uh, hello.
Hello, friend. Today, EC2
Yes,
machines public I not solve them.
sorry, somebody asking any question?
Public IP not here.
Can you be a bit loud? I cannot hear you.
All looks good, but only your submit
I- Is my voice not clear?
under the VPC.
Hello.
Click here. Delete subnet setting. Never
Sorry, I'm
Public
actually I'm
Kajaswar,
not being able to.
yeah, we cannot hear you properly. I think you have some issues with your in either network or in your sound system. You can type us as well.
Yeah, if you have any question, you can type. In the meantime, I will go to my trying to see or say what is the on the plate that we have for the coming another 2 weeks. So let me draw this thing. Not draw. I mean, try to explain it over here that we are going to have three sessions. Today's session this session, this session, the next session. So the next session, that is the next weekend, and the next to next session. Okay. So what we will have today, we will learn the theoretical background of these two tools. One is GitLab. The other one is Terraform. So GitLab is your CI/CD pipeline DevOps tool. And the other one is a provisioning tool. By provisioning, what do you know? What do you understand when I say provisioning tool? Anyone? What do you mean by when you say somebody is provisioning your telephone lines in your house? What does that mean? So provisioning means you are creating, you are building some infrastructure. Okay? It can be over your office premises, or it is over the cloud virtually. So that is a provisioning tool. We will integrate Terraform over the GitLab pipeline. The next session, we will try to have whatever knowledge, little bit of knowledge that we gathered over here, that knowledge will be implemented in form of a sort of a mini project or a mini demo of Terraform jobs, Terraform jobs being performed where? On an automation pipeline, and that pipeline is provided from GitLab. We will see this. Are you getting an idea? So today we are going to have some theoretical background on GitLab and Terraform, such that will help us to have certain hands-on activity, a very, very important session next weekend, where we will try to implement our integration of this tool over the pipeline such that we can automate the jobs that will be the provisioning jobs that will be performed over or with Terraform. Is that fine? So what about next session? So here again, we will have a theoretical knowledge of Ansible to start with, and then we will have that knowledge implemented and integrated over Ansible plus Terraform plus GitLab. So what happened is I have done certain activity over here, right? Some practical implementation of, we are going to create some resource on AWS Cloud. On this AWS, hello, hello, okay, sorry. So here we are doing some provisioning over this AWS Cloud with the pipeline. So there will be certain jobs, job 1, job 2, job 3 over the continuous pipeline. And we will not destroy it. We will let it be there. That those resources will be created. Let's say we will be creating one AWS EC2 instance. We will provision a server. We will create a server with the help of Terraform over the AWS cloud with the help of the pipeline job, and that will be automated. I will keep it. Then we will switch over to the next session, that is on the third weekend. We will learn a bit of Ansible, and then on top of this provisioned thing, we will do one thing. We will destroy this resource, and then we will rerun the pipeline, because we have already added the Ansible jobs over the pipeline in the pipeline. So now the pipeline will have So let's say this is the Terraform job 1, Terraform job 2, Terraform job 3, and then there will be Ansible job 1, maybe Ansible job 2. And finally, we are going to test from our browser, from our laptop browser. So there will be some URL that we are going to hit the endpoint of this particular deployment that we had on the some server, on the server that we have created. The end product of this particular job is a server on the cloud, EC2 instance, and that on top of it, Ansible will configure some application, some configuration will happen, and that configuration we are basically installing some web application tools, okay, with the help of Ansible, and therefore we are going to hit that, and finally our web page will be rendered on the browser. So this is our ultimate things that we are going to follow. Any questions on this? Hello? Is that more or less clear? Sorry. Is that more or less clear as to what? Yeah, Wisdom, you have a question.
Yes, for the AWS, using the AWS platform, is it going to be along the free tier, or we are going to incur some cost when we are doing this?
I still did not get your question. Are you saying that it
Okay,
will be all
I
done
was,
over?
yeah, I was saying that if we are using AWS platform, what we are going to do now, is it going to be on a free tier aspect, or we are going to incur some costs as we are practicing?
You do not have to worry about the cost part, because I will be demoing it and I will explain it over on the sessions. What exactly am I doing? Because this is an awareness session. So
Okay.
let us understand that we are not doing a full-fledged course. So therefore, you do not need to worry about how you will be setting up your lab environment at your end, in your end. Okay?
Now,
Okay.
here I would like to add one more thing. Please allow me, Mr. Devashish.
Yeah, yeah.
In our training, in our job ready courses, you are going to utilize your free tier, and AWS normally provide, I think, $200 uses. First $100 is free, so and you are going to utilize those $200 to set up your lab and practice all of the session. Even the capstone project, that is like a huge uses of AWS. We are going to use huge component in AWS part, but still it is not going to cover your $200.
Okay.
I mean, you don't need to worry about your free. It will be, of course, on a free tier environment. And during the session, we will definitely tell you, during the job ready training, we are making aware of the tips and tricks that we usually employ to save our money. At the same time, we are learning some wonderful features. So you must appreciate, nothing is free. Not a single service on this earth is free. So we are not expecting absolutely free, but I will tell you what are the tips and tricks where you can save your money. There won't be any charges limit. And even if there is a charge, and how you will avoid that, what will you do to avoid that? All these things we will discuss, but that is not important in an internship when we are going through this sort of internship sessions. Okay. Did we answer your question?
Yes, yeah, you have.
Okay.
You have answered the question.
Sure. Thank you. So let us have a last view. So what we are going to do, we are going to start with the understanding of GitLab. What is it? Then we are going to understand a bit of Terraform as well. If we cannot complete the understanding of Terraform, if there are few slides still left on Terraform, we will carry on in our next session, and then we will perform that demo, that hands-on. Okay. So right now I will just make a copy of this. Sorry, I can do it afterwards. Now, let me start with GitLab. So I hope you are being able to see the screen, right? Everyone. So we are going to learn the essential concept of a GitLab. So GitLab is a web-based Git repository. Uh, like GitLab is a competitor of Jenkins. Jenkins is a CI/CD pipeline tool as well. Very much popular. It was very much popular before GitLab came into the market. Nowadays, GitLab is basically having an interface where you can start from ideation to production. That means you can start a project from the scratch and you can end the project with the final delivery to production. That is how GitLab has been designed and implemented. GitLab is a web-based Git repository that provides free and open private repositories, issue following capabilities and wikis. So we have within GitLab, we not only have it's sort of a GitHub. It's a version controlling tool as well, like the GitHub. So if you have heard the term, there is a tool called Jira, which is a project management tool as well. I used to use this tool a lot while I was in IBM as a project manager, but it was pleasant surprise when I saw all the features that was available in Jira is also available in GitLab. Fantastic. So what we have replaced, we can absolutely do away with GitHub. Everything can be done. What you could have done with GitHub can also be done as a Git repository it's a web-based Git repository on the GitLab. That is version control tool is there, as well as it has the project management capabilities like Jira. At the same time, it is a complete end-to-end, a software development. You can enable a software development platform over the GitLab. So you can do a code repository, that is the version control of the whatever the developers are putting the code, the DevOps engineers are putting their code onto the GitLab repository. And then after that, you can have the code reviews like Karthik was saying about SonarQube. So you can also have SonarQube sort of, code reviews. You do not need to go for SonarQube separately. You can use that code review capabilities of within GitLab. Then you will have, you do not need to go for Docker Hub. Docker Hub is a place where you will collect your Docker images, which is a image repository. Here you have the image registry as well. So you do not have to leave GitLab and go to Docker Hub to fetch your images. That will take a bit of time. Here you have inbuilt within GitLab the registry. Okay. And what else? you have the champion of a GitLab. GitLab is meant for a CI/CD pipeline. It will replace Jenkins. So you do not need to create a Jenkins-like cluster. It is so simple an architecture. And of course, you do not need to install anything. In Jenkins, you need to install the entire software of Jenkins, as well as you have to build a cluster of network. It is very difficult because Jenkins have to have a Jenkins agent on each and every node in the cluster. That is quite risky. That is quite, there is a security issue in that case, because you have to you have a very agent based cluster to be maintained when you do with Jenkins, and Jenkins works entirely with the plugins. So you need to know how to code the plugins within the Jenkins. So Jenkins pipeline script is quite a bit of, there is a lot of difficulty over it. And you will see in GitLab how easy to integrate any tool, because you are dealing with the images. So in image, you are not using a plugin of that image. You are directly using an image, directly using the software as if you have installed the software over into your server and working with the commands. You don't have to install anything. The entire instance is based on GitLab runner. So whatever the jobs that you are running on the pipeline will be executed over Docker. So as if it is a Docker in Docker. It is called a DIND technology. Docker in Docker. So a container running other image, multiple images. You can have Terraform as an image. You can have Ansible as an image. You will have AWS CLI as an image. You can have Linux, that Linux kernel also as an image. Everything is an image. You do not have to use the plugin language. Otherwise, if you are using a plugin, you have to go by that, plugin API calls. We do not need to do that. GitLab is very simple. You can use shell scripts. You can use shell commands. You can use the particular declarative commands of that particular tool, like the Terraform or Ansible, or whatever you say, Docker or Docker Compose, AWS CLI. Everything will be exactly the same command that you generally use with those tools. It is so simple. You do not need to have a knowledge on Python. You do not need to do the scripting in Python script. No, nothing. You will do simple shell scripting. So what are we going to learn is you can build your CI/CD pipeline. You will learn the GitLab architecture. You will learn the basic concepts of GitLab CI/CD. You will learn how GitLab CI/CD works. You will not in the internship program in details, but generally in our job ready programs, you learn in details how from the scratch you can build a pipeline. GitLab is a DevOps platform. You can say you do everything starting from it is a complete DevOps platform. A platform on which you build your complete DevOps workflow. That is, end-to-end workflow of DevOps can be implemented on GitLab. It is like you have a DevOps platform. This is a GitLab environment. You can manage your code. You can plan your project. You can create whatever, the repositories. You can create your project from the scratch. You can verify the code. You can build the developers, the applications as a package using Maven or whatever, Maven or Gradle or Ant, whatever the building tools are there. You can use GitLab to secure your deployment. Then you can build it and package it as a release. You can use the configuration management tools to configure it. You can also use inbuilt monitoring tools within the GitLab. So basically, from the starting, that is from project management to product delivery and deployment, everything will be done. Product deploy, I mean the build, deploy, deliver and deploy. Everything can be done with the GitLab. And that is you are building an automation pipeline to take care of your project, basically from the project inception to the project delivery. So it is like we have seen, we can plan directly on the, it is like a departmental store. You do not need to go anywhere else. You just go into that, get inside the departmental store of GitLab, and you can start the project, to build the project, plan it, implement, design, and develop, and then test the product, package it, release it, and then monitor or observe how, that is on the production once you have delivered. And it can be on and on. There can be a feedback back to the planning team, or the plan you can build it from the scratch again, or rather you can continue the development again, because there could be some observation of, say, let's say the performance is degrading, something like that. That's the reason why GitLab has so many built-in features or out of the box features available for DevOps or IT projects. So what you do, CI/CD is the core part of DevOps. Like a company is producing steel. Okay, steel is a core industry. So company has a core strength of producing steel, but the company is also producing soap, some detergents. Okay, small products, byproducts. So the company in the ad is making an ad that we produce soap, we produce detergents, we also produce steel. So what they are, and the bottom line is that they are saying that we can produce as small a product like a soap and as large a product like a steel, like steel. That is what is happening with GitLab. They say that we can plan, we can do the code repository, we can use, it can be used, you can use me as a GitHub repository, you can use me as a CI/CD pipeline and all those things. But the core part is CI/CD pipeline. That is the steel type. CI means continuous integration. CD is continuous deployment and delivery. Any question up to this point? Hello?
Sir, Mirza here. So I have a question here.
Yeah, Mirza.
You mean to say the Git is working as a storage for the complete project? You mean to say here?
Yes. Not only storage, you will store your source code, the developers, what they are giving as in your version control system. That is all. That is the core part. But it is, you can start a project, you can build a project, like you can have a team of developers, of DevOps engineers as members to the project. Your testers, your operations guy, your designer, architect, everyone in the core team, in the team, as an agile project team. Okay, and you can monitor each and activity of each and every member. You will design the issues. Issues means the features. You will have the sprint backlog bucket. So everything you can do, manage the project, manage the team members, or monitor you can have the artifactory. That means you can store your artifacts, the documents that are produced from the project, the deliverables from the project. You can design the critical path. You can design your project management planning, everything that you can do sitting on GitLab. You do not need to go anywhere else.
Okay.
Yes, Mirja?
Yes, sir. Thank you, sir. Got it, sir.
Sure,
Thank you.
sure. So we will have the GitLab CI/CD. You see, your developer is merging code changes. The code changes are there. So whatever the code changes are there, they will be merging with the existing product. It is on the remote Git repository or directly on the GitLab. This is a GitHub. You can do it on the GitHub and get it cloned over to the GitLab project, get it there, or there will be an automated pipeline which will fetch the code from the GitHub, put it into the pipeline, and then get it integrated with the testing tools. After the testing is approved, you see, it can build and package. It can go through some artifact repository. And finally, so all the artifacts that are delivered, like the jar file from the Java, there are hundreds of Java files. Okay. What you do, you have to build and package. How do you do the build and package? Can anybody tell me? Let's say it's a Java or a Python or a PHP. Let's say we are taking the case of a Java. So there are lots of Java code that has been delivered by the developer. It has been put into the code repository, and there is a pipeline which will be triggered once the code commits or the developers commits the code onto the uh, GitHub repository or directly on the GitLab. So the pipeline will be triggered. The pipeline will take it to either it can be on the GitLab that it will verify the code, or it can use a SonarQube tool in the pipeline. So SonarQube, it will invoke the SonarQube tool. SonarQube will check the code, like Karthik was saying, that it will check for the security vulnerabilities. Okay, if that is passed, then the code will automatically go into the pipeline and be passed onto the testing. So there will be a system integration testing, right? And if the system integration testing is passed, then what will it do? Then there will be a final build and packaging. What are the tools that will help or will be integrated with this in this pipeline? Because that build is also a job in the pipeline. Like test is a job, like code verification is a job. Similarly, you will build and package. What are the tools that you will be integrating within the pipeline? Any idea? How will you compile a Java, lots of Java code, .java files? You have to make it one file. Let's say you have to compile it as a jar file. Jar is a Java application archive file. So how will you do that? Or maybe it's a Java web application archive, that is WAR file, either a jar or a WAR file, whatever it is. What tool will you do with?
I think is it Maven or Gradle?
Yes, yes. Not only Maven will compile it. Maven will compile. Let me have the diagram. So I'm deleting this. So What is happening? Okay. So let me do this. So what are you saying is this will be Maven or Gradle or Ant. Ant is a bit, it was very popular earlier, but now it has become a bit, the knowledge base has gone down. Either they are using Gradle or Maven. Anyway, Maven is very popular. So you will build it over Maven, but still it becomes a jar file. Let's say I'm talking about the Java. It becomes a jar file. But how will you deploy a jar file? The delivery and deployment is important. The build is done. But can you deliver? Let's say you are in this port. You are in Spain, and there are some product that needs to be shipped to India. Okay. So if your product is in the raw format, let's say that is still a jar file, a jar file or a war file. It will not be impossible, but it will be very difficult. It's a sort of a artifact type of delivery, which is not very secured and not very efficient. I will like to deliver it as an image, as a container, because the ship is running. The ship has to contain the containers. The ship will carry the product in terms of containers that will be delivered to India. So I have to put that jar or the war file as what?
As a Docker file or Kubernetes, and then it will
Yes.
be in the Nexus.
Yes. Yeah. So whatever the technology may be, but this is basically have to be an image that is my application, whether it's a Java application or a Python application, whatever it is. This will be compiled as an image or built as an image and put inside the container, because the container is the dynamic version of the image. An image is a static part. I cannot move a static thing. What I need to do, I have to make it dynamic. So what I do, I put it in the container. So the container becomes, a container is a dynamic part of image. Dynamic template of image. Right? So once it becomes dynamic, you can run it. You can stop it. You can delete it. You can update it. All these things can be done. You can query it. So all the CRUD application, create, read, update and delete, all these operations can be performed on a dynamic part of the application. So which is a container. A container can be moved from this part, from this port to this port. So you are, after the build and package, you have to do a containerization. Okay. And once you do the containerization, now you are ready for the deployment. And all these activities can be done over the GitLab pipeline. If I understand this, more or less, I have understood the essence of GitLab. Any question? So what is Artifactory? Artifact repository is something like there can be a tool called Nexus, JFrog. These are various DevOps tools which will help the company or the organization to extract and reposit or store the essential executables and the artifacts coming out of the build. Okay, so in terms of versions or in terms of releases, so these releases are very important part of operations. Operations need to know in the previous release what happened, in this current release what is happening, what is going inside production. So these releases with all its artifacts will be maintained over the artifact repository. So anyway, there are lots of things. In the meantime, I will remove this and continue with my. So CI/CD stands for continuous. We have already done it. Yeah.
Yes, sorry, sir. I just want to ask a small question with the flow there. What guarantee do we have that I'm looking at that we are simply testing the repository and then we're building, and then why don't we then test what guarantee do we have that the integrity of the image that will be formed in the artifact repository is actually the one that will really work? Because from deployment, after having experienced the deployment environment usually changes. The application starts acting in a different way than in the development part. So I was just asking, is there a way of testing the integrity of the image once it has been developed?
Yes, yes. Everything will be tested. And see, there will be the stages of your delivery. Okay. I will not directly deliver it to the deployment or deploy it to the production. There will be an approval process. Approval process means there will be a UAT, user acceptance testing, and all those things, but everything will be automated. And once there is a manual process of the job. So I will have a full control which portion I will have manual and which portion I will automate. So I will automate till the part before it is UAT tested. Everyone, the security testing, the UAT testing, everything happens. So everyone gives a green signal. Then only I will hold that particular deployment till that stage. Okay, I will not do it automatically. I will have an approval process in place, and once I get all the approvals in place, then only I will do the final deployment onto the production. See, when I deploy to the development environment, okay, so there is a final delivery, final sort of packaging. Whenever you see a approval sign, that is a right mark, that is, this is the position where I will be stopping the automation and I will take a manual approval. And once the approval is done, then there will be again the pipeline will start automatically. And so there is a way to do automation as well as manual, automation and manual. So I will stop at this part after the delivery has been done to the development server. So they will package it, they will build it and unit test it. Once the unit testing is done, then it will be deployed to the staging, that is the pre-production area. In the pre-production, there will be a UAT. So can you see there is a Artifactory and there is a UAT testing? So once the customer test and say that I'm happy with the product, and there is a security also. There will be a security testing in the pipeline, and everyone gives a green signal that it can go ahead. This can be put into the production. Then, until this point, I will stop the automation. Unless I get the entire approval, I will not release it to the production, deploy it to the production. But everything can be controlled over the pipeline. Can you see the white arrow?
Yes, yes.
That is the pipeline. And
So
there are
like, so what it means is, so what it means is, that there is actually the pipeline is a continuously, as you stated, that you put certain things in place, not allowing it to necessarily automate all the way through.
Yes.
If I get you. Oh, okay.
Yeah,
Okay,
we will see a small demo of this automation and the control. That is somewhere you will do the manual part, somewhere you will do the automation. Finally, our objective is to do an automation till a point, because you see, it is not an objective of a company to automate everything. You cannot automate everything. You can strive to automate most of the part, but there are few things which has to be done, some certain things which has to be done manually, and there, up to that point of time, you should optimize your process in automation. That is the objective. It is not that sometimes automation can be costly. Sometimes it will be prudent application of automation as well as manual. So you cannot absolutely achieve everything automated, and it is not desired. Okay, but so my pipeline has to be flexible, and how much flexibility is depends on the quality of the pipeline that you build. GitLab is of course going to help you with the options of having a combination. See, there will be a parallel pipeline, there can be a sequential pipeline. So there are lots of types of pipeline that you want to build. Parallel is of course going to cost you lots of resources. There is a resource overhead with parallel, because to maintain a parallelism is costly. Yes, the output, the end result is quite fantastic, because you are parallelly running few jobs instead of doing it sequentially. Whereas some jobs need to be done, one has to complete, then it will invoke the other. A has to complete before B can start. B has to complete before C can start. So there is also the importance of that sequence, as well as A and B and C starting parallelly. That is also sometimes important. So I have to see whether GitLab is providing me all these types of things, and with ease. I don't have to write a complicated Jenkins pipeline script to have that implemented. I can easily do it with GitLab pipelines. So you have many sorts of competitors with GitLab. Can you see GitLab? Then there is Azure pipelines called Azure DevOps. Azure DevOps is actually not DevOps on Azure, but it is a pipeline. Sometimes it is called Azure pipelines, or sometimes if you hear the terms Azure DevOps, that means it's a pipeline coming from Microsoft. CI/CD pipeline. Then this is Mr. Jenkins, very famous. This is TeamCity, Travis CI, and you also have AWS Code Pipeline. AWS has a service called Code Pipeline. So, but that is a very costly product or service, and you have to get it along with your AWS Cloud. So why not use GitLab, which can work with any sort of cloud? It is cloud agnostic. It does not depend on the cloud. You can simply build your application, and it does not depend on the container architecture. It can be Docker, it can be on GitLab pipeline can be deployed over Kubernetes and with ease, lots of ease. I do not need to go for ECS and ECR sort of mechanism. And also, I do not need to go for AWS code pipeline on AWS because these are very costly services. Advantage of GitLab is that we have given a lot of advantage, you know. It is like starting from the GitLab repository, which is like a GitHub repository, to a GitLab CI/CD pipeline. It is a source code management on GitLab, plus it is a CI/CD code management as well, all in the same place. So there is a big difference between GitLab and Jenkins. Jenkins is only a CI/CD tool, nothing else. And the knowledge base and the ease of learning a tool, this is a bit difficult. The learning curve is very steep in Jenkins, whereas it can be very easy because if you know Linux, if you know shell scripting, you can very well start writing GitLab scripts. Whereas even if you know shell scripting, even if you know Python scripting, it will be difficult for you to write a Jenkins pipeline script. Not difficult, I will say, if you learn it properly. Like my students, we used to teach Jenkins earlier with lots of batches. We have around 25 batches which learned Jenkins with us. We are running now 41st batch. I think not 25, it is around 34. Yes, it was 34th batch was the last batch which learned Jenkins with us. Then from the 35th batch, that is batch number 35, DSA 35, we started GitLab because in during that period of time, we already got the information from the market, from the job site, that the interviewers are more interested in asking questions on GitLab rather than Jenkins. Because in the meantime, GitLab was getting very popular. Okay. GitLab it can have a seamless integration into the code repository using CI/CD without overhead setting it up itself. So you do not, here you have to set up the entire pipeline and you have to you have to go for a Jenkins cluster. Here there is no, you do not have to do a single bit of installation on GitLab. Okay. Because the GitLab provides you just have to create an account. Like in AWS, you create an account and that's all. You start working on the cloud. Here also in GitLab, you just have to create an account and that's all. You start building your pipeline. You can start building your project from the very scratch, whereas it is not the same case with Jenkins. So see, Mr. Jenkins is closing his eyes to the reality. Pipeline configuration as a part of your application code. So your pipeline configuration is a code, and that is very important because the DevOps tools are very good if you can code it. Coding means you do not need to be a developer. You do not need to learn Java or C++ or PHP, Python. No, nothing. Simply you know shell scripting, that is more than enough. That's why we observed that the moment we started Jenkins, many of our students started getting disinterested. But here the scenario is just the opposite. The GitLab is so easy to pick up and easy to start. You start from day one because there is no installation part at all. Everything you do is without installation. You do it with your images, and images you do not have to. That is the best part. Images, you do not have to install. Images, you have to just attach, have it on the pipeline. Okay. And there is the GitLab runner, which is self-hosted, or it can be SaaS managed, software as a service. It can be a managed GitLab runner. So I will not go into that details because I think we have one more hour to understand Terraform as well. So I will just go in a part that this is the GitLab architecture. This is a general question. If you don't have to set up anything, then how does it happen actually? Yes, because you are given a installed GitLab instance. You just create an account. Your GitLab instance is available. You do not need to worry where it is. Only the runner part, because you want to have your self-hosted runner. Okay, so you will install that. You can install that on Windows or Mac or on a EC2 instance, whichever you prefer. And once you have that, your project, you are building up a project, okay, on the GitLab instance, you just register the token of that runner into the project, and after that you can forget about this. So your project will be having that registered runner. It is that simple. Or you can have the agents, which is SaaS managed, that is managed by the GitLab, which is called a shared runner. And shared runners are not very safe. And rather, when you work in an organization, you will be using a self-hosted runner, because your organization will not like to have a shared runner, because shared runners can have a less performance, not a very efficient performer, because there will be time slicing between all the projects that are sharing that runner. So why to share the runner? You have your own runner, and as a DevOps engineer, you need to know how to install your self-hosted runner for your company. You don't want to have the inbuilt runners, the shared runners. So you see, this is a self-managed. You are managing your, or you are not using the managed or SaaS runner given from the GitLab. You will do it self-managed. That is where your importance as a DevOps engineer happen. Okay. These are the things that we are going to learn in details in our job ready training. But then you see, you have a GitLab.gitlab-ci.yaml. That is the heart of the pipeline, GitLab pipeline. Here, this is a YAML file. YAML file is a format of exchanging the data over the internet using JSON, JavaScript object notation. Okay, I will not go into that details, but you will write your declarative script within the. It is like a shell script. You are writing within the this particular YAML file, configuration file. So you are coding your pipeline. That is a very important aspect. You can, if you can code something, that means you have everything under your control. Whether you will make it manual pipeline or you will make a combination of manual and automated, it's all under your control, because you can code your pipeline as per your wish and design. So these are the jobs that you are executing in the pipeline with the pipeline runner, and that's why you are writing a YAML script. So basically, these are the jobs. Job 1, job 2. So tomorrow, that next weekend, we are going to demonstrate Terraform jobs. Terraform job 1, job 2, job 3, job 4. We will do that, and we will see that on this pipeline that we have built, we are executing the Terraform jobs and we are doing some provisioning activity because Terraform does some provisioning. And once we have provisioned our server, we will keep that. And on the next to next weekend, we will have Ansible configure something onto that server. And on the very same pipeline, that is the beauty. You will extend the pipeline. You will integrate more and more tools to make your job a versatile job. Got it? Any question? This is in a nutshell what you do. So right now, do you have any question? Because I'm going to switch over to Terraform. Just to understand, Terraform is a tool, DevOps tool. GitLab is a pipeline tool with so many other activities that it can perform. But our main importance, our main focus is to see how the pipeline works and to create the pipeline. What about your question about if you have any questions? Because before we jump over to resource provisioning, yes. Someone asked about resource provisioning. Did you, Priyam Maiti, are you there still? Priyam? No. Sorry, I could not attend because I was not being able to see your chat. You could have easily unmuted yourself and could have asked any question. So if there is no
Hello, sir.
question,
Mirza.
yeah, Mirza.
Sorry, actually, I think this is the question which I am answering. This is not related to the current topic, actually. So, can I go ahead and ask?
Ask what?
I mean, so what is the role of a DevOps engineer here? So,
Good. The role of a DevOps engineer is like you will bridge the gap with between the developers and the operations and the testers and the project managers and your program managers. So, and also with the business owners, okay, who are sponsoring the project or who are sponsoring the product. So your role is a multifaceted role. It is not constrained or it is not within any framework. You are not a developer as such. You are not a tester as such. You are not absolutely an operation guy as such. You are not even a project manager. Okay. You are not a architect. You are not a designer. But then who are you? That is a vital question. You are a DevOps engineer because these tools, if you have not attended my first session, it will be difficult for me to answer. Did you attend my first session on introduction to DevOps?
no, sir. This is my first
Uh,
session. That is why I asked you.
yeah. So that is the reason. But we have passed that stage. So in short, your day-to-day activity will be to be a friend with your developers, because many developers will be there. They will every time come to you to get your help. What sort of help? That they will they have developed a product or they have developed a code, and they would like to understand from you how to store that into the code repository, a version control tool. Like it can be a GitHub or it can be a GitLab. So they do not know, they do not understand the technology, what to do after they are experts in Java, they are experts in C++ or Python. They write codes, complicated codes. But what then? What next? They do not know how to pass it on to the testing team. How to pass it? So you will step in. You will build the environment The development, like the developer who has joined new does not know where to start. What is the starting point? The project manager will direct the development guy to contact you as a DevOps engineer. You will provide him the environment, a development environment. How? You have the tools. You know the tools like the cloud, Git, GitHub, Linux, you know um, Terraform, Ansible. So you will know all these tools and you will build up an environment for the developer to start working on it. Isn't that a vital work? Then there is a testing guy who has come to you to say that they do not know how to get that particular code to get into their environment, test environment. So you will build a test environment for them, and then you will deploy the product that has been delivered onto the GitHub repository or the GitLab repository by the developer with your help, of course. Then you will deploy it to the test machine, to the test server that you have built. And maybe you have installed Selenium onto the test server. And yeah, you may not know, they are experts on Selenium. But to get them the head start, you are the person. Then the operations guy will meet you and say that we need a pre-production environment because our customers are going to test that product. So you will take all the inputs from the testing team, whether the test has been done correctly. If not, you will again redirect with some mechanism. You will redirect back to the developer because the developers have to rectify the bugs which has been found by the development testing team. Then again, so this flow will be maintained and coordinated by you. Then the operations guy will come to you saying that I will need a pre-production environment with this sort of environment. They will give you the tuning parameters and they will say what should the network look like? What are the parameters of the network? Or what are the parameters of storage? What is the performance requirement metrics? All these things will be specified to you. You will build up that environment with them. And then you will integrate the test server with the pre-production server. And you will integrate the development server with the test server with the pre-production server. Through what? Through a continuous integration pipeline. So you have to build the pieces together. You will join the pieces together. And that is what your role is. You are a member of the project team. For any software development project, you are a member. You are a constant member. The testing team can vary from project to project. Okay, because one project is a Java project, one project is a Python project, one project is a combination of Java and Python. The one project is a PHP project. Okay, so the testing team will vary because on the expertise, but you are constant. You are a part of all the projects. Did I answer your question in a
Yes, sir. Yes,
short
sir.
Okay.
No, sir. It's perfect. I got it, sir. Thank you, sir. I really appreciate. Thank you.
Thank you, Mirza. So let us go to our Terraform. So Terraform is a provisioning tool. So today, forgive me because I am not being able to show you the hands-on. Just have patience. The next session, we will have complete hands-on of how we integrate Terraform on the GitLab pipeline. Okay? We will see that. So Terraform, I will not go through much of this writing. Terraform is like a provisioning tool. It is a tool for building, changing, versioning infrastructure. So it will build an infrastructure on the cloud, on any given cloud, whether the cloud is AWS Cloud or Azure. Azure is a Microsoft cloud, or GCP, which is a Google Cloud, or maybe Oracle Cloud or IBM Cloud, whatever cloud. Okay, so it can provision from outside. Like in my usual job ready training courses, in my DevOps courses, we used when we learn AWS, we learn the cloud formation. So cloud formation is an automation of a provisioning on the cloud. Either you can use the AWS console with the cloud formation service, or you can do it with the AWS CLI from outside the console with the help of AWS CLI command, cloud formation command. Okay, so that is a different topic, but then that is a product from AWS, that cloud formation. I cannot use that product for configuration of resources on the, or resources, I mean the infrastructure. You cannot provision, you can provision that with cloud formation. But tell me, can you use cloud formation on Azure Cloud? Azure Cloud has Bicep. Bicep is a configuration, provisioning tool provided by Microsoft Azure that can only run on Azure Cloud. Cloud Formation, AWS Cloud Formation, which is a service, can only run on what? AWS. So can you see that they are bound to each of the technology? So your VMware SDK will work on only the VMware cloud, or the VMware cloud. Okay, so it will not work on Azure, it will not work on AWS. But so let's say today you have learned about cloud formation, but you have got a job with a company who is using Azure Cloud. Will your knowledge of cloud formation help? It won't. You won't be able to use the AWS Cloud Formation on Azure Cloud to provision the resources. So you need something which is cloud agnostic, which does not depend on the cloud. Here it is, you have a provisioning tool called Terraform. Terraform can work with any cloud, and there are almost like more than 75 clouds in the market. So you give Terraform the appropriate plugins, and then it can make an API call to any of that cloud. So the key feature of Terraform is infrastructure. You can code the infrastructure, like you can code the pipeline over the GitLab. Similarly, you have the power. If you can code something, and the coding is so simple, and these are the declarative scripts you create, and there are umpteen number of help, the documentation, examples. So you won't find any difficulty. You will just copy and paste and just change few things. That's all. Just change the data. The parameters will remain the same. You can within minutes code an infrastructure. As simple as that. You can have execution plans. That means before you apply your plan, you can see your plan, whether the plan is according to what you desire. Okay, that is one very important step. So you can have complex chain sets. So on the fly, you can change the automation. It is a bit advanced concept, but it is possible. That means as per the, see, let's say you have built a script, for an example, you have built a script for your development environment. That environment is development environment. Okay. Now you have to adapt that script for a testing environment, right? Because the platform changes from development to testing. So your code should work automatically based on the platform you are using automatically. So you can configure with the chain sets, you can configure depending on, you can grab, you can extract the environment, and based on the environment, you can adapt your script. You can adapt your script. Hello, can you see my screen?
You can.
Yes.
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 Yes. So I'm not going to that much of complication because I don't want to complicate your lives. It's just a generalization or rather awareness building sessions that we are having so that you feel interested. You know what you are going to learn in future, whether you are at all interested in DevOps. You may not. Of course, we have to value your interest, because if you see after attending the internship program on DevOps, you see, no, it's not your cup of tea, or you do not find any interest in this. You rather go for maybe AI. Okay, nobody will stop you. But this is just from an effort from our side to just build up your awareness. That is the whole purpose. So I will rather change my, the approach. I will not go into that details. Changing the automation on the fly is one of the key features of Terraform. So it will be you can have any types of cloud, whether it is Azure or Google Cloud, or this screen is a bit, that picture is a bit hazy, but I will tell you that this is the symbol of Azure Cloud. This is the symbol of Google Cloud, and this is the symbol of or logo of AWS Cloud. And here it is the logo of Terraform. So you will use the Terraform scripts to create the infrastructure on various cloud. So you need to have a provider plugin, and that plugin will be downloaded according to your cloud, and that's all. The respective API calls will be depending on the plugins that you are using. So it will not build your code over or the resources over GCP if you are using AWS plugins. It will directly do it over AWS Cloud. Why do you need infrastructure provisioning? See, in the CI/CD pipeline, we need to create various test, pre-production, development environments according to the organizational QA policy. What is QA? QA is the quality assurance. So your product has to pass through test, has to go through pre-production, and then only, and the development environments, and then only it will, if it qualifies and passes the quality assurance policies, it will then be provisioned over the production. To create test environments, we might also need to create virtual infrastructure on the cloud, hypervisor, VMware, Hyper-V. Or directly we can use the cloud plugin without any issue. We are not going to use hypervisor or VMware, hypervisor. So we are directly doing it over the cloud. We are going to provision over the cloud. To automate this infrastructure creation, updation, we need some kind of a tool, and these tools are called the infra provisioning tool. You know the cloud model of service model. One of the cloud service model is what? IaaS. What is IaaS? If somebody has done the AWS session with us.
Infrastructure as a service, sir. Infrastructure as a service.
Infrastructure as a service. So that is a service provided by AWS. Or there are lots of infrastructure as a service services. Similarly, in Terraform, you are saying infrastructure as a code, IaaC. So you are using Terraform as a coding tool to provision over the infrastructure over the cloud. IaaC versus IaaS. Depending on the infrastructure used in the organization, we will have different tools which can help us in automating infrastructure creation. You see, AWS has a service called CloudFormation for automatically provisioning the resources over the AWS cloud. Azure will have Bicep or ARM templates. So Bicep is used over Azure to automatically provision resources. And here you have on the VMware, you have the VMware SDK, okay, which will help to provision automatically on the VMware. But VMware SDK cannot work on Azure or AWS. Similarly, CloudFormation cannot work on Azure or VMware or any other cloud. But you see, you can solve this problem, proprietary issue problem. Earlier, when there was AIX, when there was HPUX. So if you have worked on HPUX, you will not be able to work on IBM AIX. Okay, they are two different, both are operating systems. But learning one operating system will not help you to work on the other operating system because they are tightly coupled with the hardware, with the hardware machine, with the server. So if it's an IBM server, you cannot work with HPUX. If it's a HPUX, you cannot work with AIX, which is from IBM. But if you learn any Linux, whether it is Ubuntu Linux or Red Hat Linux or Amazon Linux or SUSE Linux or CentOS or Debian, any Linux you learn, you can apply the same knowledge because the commands are not going to change anywhere in any platform. Similar thing, Terraform in the light of Linux. You learn Terraform, that's all. You can provision any resources on any cloud. You just have to learn Terraform. Okay, so this is not much of an important bet because a developer who has joined new, who is a fresher, he is much concerned of asking questions. But most of his 99% of his questions to the tech lead or to the team lead will be how to do the work, how it has to be done, how is the important thing. But he is an experienced professional. You see, he has grown the beards. Okay, so he's almost like 5, 6, 10 years experience in that organization. He will, whenever he is talking to the team lead or the tech lead, this person is always talking about what has to be done instead of how it has to be done. Okay. So when you are talking about how it is, you are thinking something in your mind which is very procedural. That is, you are asking questions based on your knowledge of a software development language. If you are a Java guy, you always convert the house into the Java language. You cannot think the bigger picture. You do not think from the business perspective. But this guy who is asking all about what? So basically, he is more into what is the requirement, what needs to be done. He's not concerned how it is to be done because he knows he has the tools. The tool will take care of the how part. And those tools are the DevOps tools. DevOps tools will answer the how part. You have to ask question to the DevOps tools as what has to be done. So that what is nothing but a declarative. You declare, you write not the Java language, Java programs or PHP programs. You write a declarative script. You are writing not a programming language. You are writing a script, declarative script. It does much more than what you can do with a Java thing. Okay. So Terraform is like a declarative approach to specify what your infrastructure needs are, what you want to do, what you want to create, what you want to provision. So you declare that, and that this is my desire. So that desire is nothing but a declarative. And this is famously known as infrastructure as a code, IaaC. So the workflow is very simple. This is the DevOps guy who will write Terraform configuration file that will be fed into the Terraform engine. Terraform engine will process this Terraform files and deploy the resources, create the resources over the cloud. It can be OpenStack, it can be Microsoft Hyper-V, it can be VMware, it can be Azure, it can be Google Cloud. So you just have to write the declarative configuration files and call the appropriate API calls through the provider, that is the plugins, whether the plugins are from AWS or Azure or any other provider. So the API calls will go to the respective cloud. Terraform integrates with different clouds through Terraform providers. Terraform is a cloud agnostic because it can deploy to any cloud or virtual infra provider. So there is a desired state and there is a current state. You always try to change the current state to the desired state. So let's say you do not have a EC2 instance. You want to create one instance. So what is the difference? You will write some declarative script on Terraform to create one state which is not there. So there is a difference between the something which is not there and something that you desire. So if there is a difference, then you will end up creating the desired state. You simply think of that. Suppose you have already created or provisioned that server, that EC2 instance over the AWS cloud, and now you are doing it again. Will there be a difference between the desired state and the current state? The current state already has that server. Can you do it again? It will not. It will not do, because your desired state versus the current state, there is no difference. There is no delta. Okay. So it will only refresh the state. It will not create. Now, the current state that there is a server. Now you desire to destroy it. Will there be a destruction? Will you delete or drop that server? Yes, because there is a difference. The current state there is, and the one that you need is to destroy it. So there will be, when you apply it, and Terraform commands are very small and short and cute. You will love it. So I think It was a constant, I mean, it is almost like 1 hour, 40 minutes. Okay. Or maybe a bit little less. Doesn't matter. We will do hands-on on the next session. We will not only have a Terraform thing, we will create Terraform scripts and deploy it over a pipeline to see how the jobs are executed one after the other on the GitLab pipeline. We will build a project, simple mini project we will do. Is that fine? That is, once we do it, yeah, thank you. We will do it on the next weekend. Don't miss that session. So, Mr. Menon, I think I have done the session. You can take over, or if there is any questions from any one of you, please let me know. I see there are lots of students have dropped off. It is very natural because it is already it is
4 hours.
4 hours at a stretch, and also it is quite a night in India. So
Yes.
the Indian guys mostly have dropped off. That's fine. So Priyam, you were asking something I could not see at that moment. So you were saying that something about provisioning. So I will hide my face now. Yeah. Yeah, I know it is too much. Two things, two big tools. One, the GitLab, and the other, the Terraform. It is not at all desirable, and we do not do it in our actual sessions, in our job ready sessions. We do a lot of in-depth study. Here, I have just covered on the very superficial, or not on the very surface of it, not superficial, surface of it. I have just given a overview of the tools. And while we do the hands-on on the next weekend, we will understand a bit of it, not if not all.
So I think we are at the end of the today's session. We can stop recording. And guys, if you have any question regarding anything DevOps, cybersecurity, or main courses, or the job market, about your job hunting process, feel free to ask questions.